Welcome to the part 1 of the training module called External Control Interface for Mobile Manipulators. This module is in direct link with the previously introduced use case 13, which is deployment of mobile robots in collaborative work cell for assembly of different product variants. In this video, a general introduction of the Trinity module will be provided, following with a quick overview about the main purpose of using this module and what is the added value of the module in the industry. Next, we'll cover the following aspects starting from the basics with a bit of technical content. These topics are as follows: module purpose, hardware overview, software overview, prerequisites required to use this module, input, output and their intended use, software environment which is used for programming, and then finally finishing with a general conclusion and providing a quick overview of the next training. This module is related to the use case 13. The main industrial benefit was already introduced in the previous introductory video. The proposed Trinity solution could contribute to agile manufacturing by enabling the quick deployment of mobile robots for transporting different parts during manufacturing operations. The mobile manipulators could enable the realization of autonomous and agile manufacturing that can cope with variability in the manufacturing processes and provide extensive flexibility in assembly operations. It aims at providing a solution for deploying mobile robots in collaborative work cell for assembly. This first training is a very general introduction to the module. Even if we will cover some more technical part at the end, today's training material does not require any specific expertise, but just basic knowledge in Python and Java programming language should be sufficient. The solution presented in this Trinity module is the external control interface for the mobile manipulators, the motion class implementation which bundles up different functionalities of the mobile manipulator following the skill-based approach, and a graphical user interface for the operators for easily controlling the operation of the mobile robot. Let's start with different hardware components that are required in order to properly use this module as intended. The module focuses on the external control of the mobile manipulator through an implemented parameterized motion class on the robot controller. This interface could be adapted and can be used with any robot brand. As this module was validated in the general use case where we use a KUKA KMR IVA robot. We will use the same hardware setup in this training material. The following minimum hardware is required to properly use the module. The main hardware is the KUKA KMR IVA robot, which is you can see on the right. KMR stands for KUKA Mobile Robotics, and it is a combination of the sensitive LBR IVA lightweight robot and a mobile flexible platform. As the name and the individual components already suggest, the KMR IVA stand out with its high degree of mobility and flexibility. You have a computer on the left, which is the external control computer. This computer is responsible for external control and communication via UDP and TCP/IP with the robot, as certain ports are enabled on the robot controller. The following port numbers, client or server socket, can be used in a robot application. That is, the ports are 30,000 to 30,010. This basically means that you can create a simple UDP server on the robot which can listen to the messages sent by the external controller on the specific port. Importantly, UDP messages can be structured and can be customized to the specific needs, giving flexibility for the communication. Furthermore, the motion class has been implemented in the control computer, providing communication interface for the toolbox and the functionalities of the robot in the form of device primitives. That is, go to location, go to node, get current location, etc. On the right, you have mobile robot controller. This consists of an industrial PC which is built into the AGV system and the actual navigation software, that is KUKA navigation solution, that manages all vehicles and coordinates planning. KUKA navigation solution enables autonomous navigation of mobile platforms with no risk of collision and without the need for artificial markings. The software acquires all the data from the safety laser scanners and wheel sensors and uses them to create a corresponding map of the surrounding by means of the SLAM method, simultaneous localization and mapping. The system responds to changes in the environments which occur frequently in a flexible logistics system. An Eclipse-based development environment can be used to program application in Java. The modular Java API with suitable interfaces for the requirements of mobile robotics allows the integration of third-party software. Let's now dive into the software architecture of the Trinity module on the slide. You can see a simplified representation of the different components in this module. First, the core of the module is the user interface and the robot commander. This is the web page where you can control the operation of the mobile manipulator. The user interface is built using Python Flask Server API. Flask is a web framework for Python, meaning that it provides functionality for building web applications, including managing HTTP requests and rendering templates. This server is also communicating with the robot commander to transmit user inputs and getting feedback from the robot commander module. Next, you have another important module, which is the device driver, which is responsible for controlling the navigation server of the mobile manipulator. The device driver is implemented in Java-based application running on the mobile robot controller. The KUKA navigation solution provides a Java API to control the mobile robot using its mobile robotics API interface. The device driver is receiving commands over UDP port via Wi-Fi from the robot commander and providing feedback of the robot status. And then you have a graphical user interface for the operators. Using this graphical user interface, operators can easily control the robot operation and also visualize the status and feedback from the mobile manipulator. This slide shows you how the module is intended to be used. You can see on the left side what are the inputs for this module. You have the operator that will interact with the module through the user interface. In the middle, you have the web interface, which will eventually control the robot and robot operation. The status of the robot operation can be visualized by the operator through this interface. This slide discusses the prerequisites which are required for the mobile manipulator to operate autonomously. For autonomous operation, KUKA navigation solution software acquires all the data from the safety laser scanners and wheel sensors and uses them to create a corresponding map of the surroundings by means of the SLAM method. Locations of interest should be defined and virtual tracks should be made for allowing the platform to move exclusively along defined routes. These parameters are then used by external control interface for commanding the robot. Native application of the Trinity module should be installed as the device driver in the robot controller. We can dive into the software environment. For the robot application programming, an Eclipse-based development environment called Sunrise Workbench IDE can be used to program applications in Java programming language. The modular Java API with suitable interfaces for the requirements of mobile robotics allows the integration of third-party software. The external control interface is implemented in Python programming language, which uses Flask API for setting up web interface and Socket API to establish communication over UDP protocol to send and receive messages across the network. The developed module works on top of the native navigation solution, which is the KUKA navigation solution, utilizing proprietary software and autonomous functionalities of the mobile manipulator. To conclude, in this video we have provided an overview of the software and hardware architecture, prerequisites which are required before using this Trinity module, and also for setting up the autonomous operation of the mobile manipulator, the input and outputs which are related to this Trinity module, and the software environment in which this Trinity module has been set up, and the languages which are being used to program different device drivers and applications.